How are project uploads performed via the Telediogram program? Let's take a look together. First, we place a binary register and a digital output block on the screen and establish connections between the blocks. In the lower left part of the screen, we have the Upload to Device section. When we click here, we see options for connecting via TCP or a USB cable. Let's first proceed with a USB connection. We choose the COM port and click OK. The connection between the device and the computer is established. We click OK. In the next step, when we click Send to Device, we upload the relevant project to the PLC. The screen prompts whether the existing project in the device should be saved. If we say yes, we can later retrieve this project from the device. At this stage, we can also say no, meaning we don't save it inside the device but can proceed to the next step by saying Upload to Device. After the project is transferred to the device must be reset. Therefore, the answer to the question of whether to reboot is yes. At this stage, the error LED on the device lights up. Let's not attempt any connection on the device until the error LED turns off, as it may take about 7 to 8 seconds to reset. We re-established the connection via USB. Let's observe the statuses in online monitoring. The red and blue visuals around it indicate the activity status of online monitoring. We made it 1 to 0 and controlled the digital output with the binary register block. Now let's take another block on the screen and perform the upload via Ethernet. Let's perform the upload via Modbus TCP. For the Ethernet connection, we enter the IP and port settings of the device in the device configuration area in the projects section. We define the device's IP settings by entering the microterminal under the Tools section. First, we select COM3, the COM port, and connect to the device via USB. In the Ethernet section, we enter the local IP, gateway, and netmask. If we press R or say red, we display the current IP settings within. If we say write, we change the settings in the relevant box, and by saying write again, we define the IP settings. Let's change the IP address. The device needs to be restarted to detect the IP change. For this, a new project can be uploaded to the device, or we can restart the device by sending 1 to the @reset command in the internal FS section and saying write. Meanwhile, because the COM port connection is toggled on and off, we need to toggle it on and off again to receive the relevant query response. The device is resetting now. Meanwhile, let's provide this information. The device retains the last state of digital inputs and outputs when powered on. We've made the IP adjustments. This time we establish a connection using TCP. When we say OK, the connection between the device and the computer is established, and as seen, there is a visual change in the Ethernet socket. Let's send the newly designed project to the device. Again the same warning. This time let's say yes, meaning also download the current project. As you can If the port number needs to be changed, we can perform a connection between a TCP socket and a Modbus TCP slave by selecting TCP driver and changing the listening port, which was 502, to 503, and then upload to the device. With this configuration, the listening port of the device is now changed to 503. Now let's do online monitoring, this time live monitoring over Ethernet, and change the values. When we write 1 with the binary register, you can observe that both outputs are active simultaneously in your work. This time we performed the upload via Ethernet with the device. That is, if you are in the same environment as a device in the field, you can perform the upload in the same local environment, or if port forwarding is done, you can perform the upload Similarly, we bring the Modbus TCP slave and TCP socket section on the screen. The media type is set to GSM. Inside the Modbus TCP slave, you can also change the slave ID. Let's perform the device upload in this way. Later, for GSM settings, we open the microterminal from the Tools section. We talked about the Internet before. Now we come to the GSM section. Our first query is GPRS APN. APN addresses of SIM cards can vary according to different operators. You learn this from the operator. We enter the relevant APN address here. I am currently sending a query to @+ connection in the socket status section. And I get 4 responses in each query. This means the device is trying to acquire an IP at this stage. If the device acquires an IP, our response will be 6, and if we come to the GSM section and query @+PERSUP, we will learn the device's IP address. And now the response came as 6 or 8. Coming to the GSM section and querying GPRS IP. If I later copy the static IP and paste it back into the project section area, and enter the defined port in the TCP socket block here, I then access the device over GSM and the upload or online monitoring operations are carried out over GSM. As seen, if it is 554, we enter the defined port in the TCP socket block into this area as well. In the next step, Wi-Fi. We selected Wi-Fi for media types. The device we are currently training on has both Ethernet and GSM. Let's talk about the Wi-Fi section. In the Wi-Fi settings section, we have the Wi-Fi passport and Wi-Fi SSID area. Our SSID area is the name of the modem. In our Wi-Fi password section, we enter the password of the modem. Then in that section, we can make the IP, NetBus, gateway settings for Wi-Fi. Since the device does not have Wi-Fi, every query returns an error. If it had Wi-Fi, like with Ethernet, you could query the IP address, gateway, say red, and make the relevant IP definitions. Since the device After the definitions are made, TCP is selected to connect to the device and the IP address is entered via the defined IP. Additionally, to check or change the IP and port information before the connection, click on the Settings option next to the TCP Connection option and go to the TCP Connection Settings page in the Projects tab.